Bueno, buenos días a todos. Para los que no me conocen, mi nombre es Gabriel Rodríguez Garrido, soy director ejecutivo del IPA, del Instituto Petroquímico Argentino. Y bueno, como saben, organizamos periódicamente este tipo de webinars o charlas de actualización sobre temas que, bueno, que nos importan en la industria. En este caso, hablamos mucho del tema de la transición energética y bueno, la implicancia y el rol que la petroquímica tiene en este camino. Y bueno, nos pareció sumamente interesante la presencia, digamos, de Matthias Stein de Liquide, que nos va a comentar sobre justamente las tecnologías y distintas facetas del metanol. Primero vamos a tener una pequeña introducción de Liquide por Marcelo Fermepin y luego Matthias Stein. Marcelo.
Bueno, buenos días a todos. Gracias, Gabriel, por la introducción. Yo voy a compartir mi pantalla. Bueno, para los que no me conocen, yo soy Marcelo Fermepin, trabajo en Air Liquide E&C, que forma parte del grupo Air Liquide, y estamos en el área de lo que es todo tecnología y producción de plantas y diseño de plantas. Así que voy a compartir mi pantalla. No sé si me puedes confirmar, Gaby, que la están viendo todos.
Ahí está.
Pero...
Perfecto.
Ok, perfecto. Bueno, a esta presentación la hemos llamado El color del metanol. Después Matthias les va a explicar un poco más de qué se trata. Yo voy a ir rápidamente, para los que no conocen el Liquide, voy a dar un pantallazo de cómo la compañía, digamos, está formada y dónde trabajamos del lado de lo que es E&C o Ingeniería de Construcciones de Liquide. Segundo. Ahí va. Va un poco lento. Bueno, la presentación del grupo. Para los que conocen Air Liquide, nosotros tenemos, dentro de lo que es el grupo Air Liquide, estamos enfocados en dos grandes áreas. Uno es la industria y la otra es la salud. Nos han conocido durante el último año, lamentablemente, mucho por el tema de salud. Pero bueno, la empresa es transversal y atiende a todos los procesos y tecnologías y industrias. Estamos obviamente en todo el mundo y somos una empresa líder en gases y tecnologías. Tenemos más de 67.000 empleados, estamos presentes en 80 países, más de 3,7 millones de pacientes y clientes. Nuestra facturación es de 22.000 millones de euros, esto es del año 2019, y con un net profit de 2.200 más o menos, el 10% de lo que es net profit. Tomamos decisiones de inversión por 3.700 millones de euros al año. Este es nuestro esquema de negocios. Como verán, es muy variado, pero lo importante ver acá es que somos transversales a todas las industrias. Atendemos de lo que es electrónica, lo que es industria de gran volumen, como puede ser química, refino y metales, a través de cañerías. Atendemos clientes industriales fraccionados a través de gases líquidos y también a través de cilindros. En lo que es ingeniería de construcciones, damos servicios a terceros y a Air Liquide en lo que respecta a diseño de plantas y a proyectos. El grupo se basa en tres pilares en lo que son la tendencia hacia el futuro, que es la energía, la transición energética, que eso es lo que vamos a hablar un poco hoy, la digitalización y lo que son los cambios en lo que es healthcare. Nuestros objetivos para el cambio climático son la reducción de un 30% en lo que es la intensidad de la huella de carbono de Air Liquide para el año 2025 en relación a lo que fue el 2015. Ayudar a nuestros clientes o acompañar a nuestros clientes en todo, en todo lo que son sus procesos y en la mejora de los procesos, llevándolos a procesos más limpios y ayudar a nuestro ecosistema en la reducción de huella de carbono. En lo que respecta a E&C, que es el área de Ingeniería y Construcciones de Air Liquide, somos el grupo que que da servicio a terceros y también dentro de la compañía a la que es construcción de plantas y diseño de tecnologías. Tenemos 60 tecnologías de propiedad, más de 1.600 patentes. Tenemos 15 centros de ingeniería que nos soportan y 3 centros de manufactura, 3 workshops. Acompañamos a nuestros clientes en todo el proceso del proyecto, en todas las etapas del proyecto, desde lo que es el estudio de factibilidad hasta la operación. Hay una característica que tiene el grupo, que en lo que son algunas tecnologías que el propio grupo usa, tenemos un ciclo de aprendizaje. Al operar nosotros nuestras propias plantas, podemos dar feedback a Ingeniería de Construcciones para que mejore sus diseños. También actuamos como licenciatarios en lo que son las licencias del grupo, ¿no? De Liquide. Bueno, esto es un poco el mapa de donde estamos ubicados. Como les dije, tenemos 15 centros de ingeniería. Los 3 centros de producción están en Francia, en Ras Al Khaimah en Arabia y en Hangzhou en China. Bueno, yo llegué hasta acá. Esta es la presentación en español. Ahora va a continuar Matthias, al que le voy a pasar la presentación para que él pueda seguir con su parte. Muchas gracias a todos.
Si les parece, como dinámica, digamos, vamos a tener la presentación en inglés, como habíamos puesto en la invitación, y hacia el final vamos a tener un espacio de Q&A, ¿sí? De preguntas y respuestas. Así que los invito también a que escriban en el chat. Y bueno, y vamos a poder tener un espacio que voy a moderar más adelante. Así que sin más, Matthias, all yours. We will have some time at the end of the presentation in order to have a little discussion if someone has questions. So all yours, Matthias. Thank you.
Matthias, you are on mute.
So now I'm unmuted.
Yeah.
And first of all, thank you very much, Gabriel. Thank you very much, the IPA team, for inviting me to speak today. Thanks to Marcelo that he prepared that well and that he did the sales pitch for Air Liquide. So I'm now going into the presentation. Let me share my screen with the presentation again. I'm not too familiar with Zoom, and so far
This
I have to.
is down in the screen.
Yeah, I have it here. So let me see that this is
Now it's working. Okay, so present.
Yeah, you can see it, right? Okay, very good. Very good. So this slide we already had. Let me skip the Air Liquide slides.
Yeah.
And, let me go to the colors of methanol. I thought this is an interesting subject to share with you, and I'm happy to take questions at the end. So let's go through it and let's look at that. First of all, methanol. You all know methanol. It's the seventh largest commodity chemical in the world. Very large production, a bit more than 100 million tons per year are produced, and it's growing in a good number at 3.5% in an average per year, a bit more in China, a bit less in Europe. I think South America is right in the average. It is, and that's interesting, a potential sink for CO2 because methanol contains a carbon molecule. So we can use methanol as a sink for CO2. If you, at the end of the day, if you use methanol in fuel applications, so when it is burned, then of course you have the problem that you are emitting CO2 again. But if you use it in petrochemicals, in polymers, then these are the durable applications, and then your CO2 disappears in polymers until you dispose the polymers somewhere. It is one of the lowest cost liquid chemicals to store energy. Let's look at that slide. It is methanol may be a part of the carbon capture discussion. So blue methanol, where CO2 disappears in methanol. I just described that. The discussions we are having at this time are a lot about green methanol, where you would require a green feedstock, ideally hydrogen, or maybe also biogas. But there's a lot of a discussion around green hydrogen, which requires electrolysis, investments into electrolysis, and it requires green power, which usually comes from solar or from wind energy. And all of that is very costly. All of that makes renewable a renewable product, but it is very costly. And it depends very much on how much is your green power you are sticking into the plant. And that is a big discussion in Europe. And I know it's also a big discussion in other parts of the world, and it's coming also in South America. A problem in Europe is that power is extremely expensive, and green power is even more expensive. And then you have to look at the cost of CO2 conditioning. You have to purify it. What is the source? Is it green? Is it renewable? Is it bio? So it can be expensive as well relative to natural gas feedstock. So as I said, there is a big market discussion about CO2 capturing and renewable methanol, and the volumes that are sold green, renewably produced in the world is just 200,000 tons, nothing more. And some of these volumes are simply from trading CO2 credits. I'd like to share this chart with you, which is an overview over the, let's say, colors of methanol. Traditional way of doing it on top is the gasification of coal and oil, and you get syngas and a coal and oil based methanol, which is has the highest CO2 intensity. The much better is the use of natural gas, and in fact, roughly 50% of the world methanol produced is based on natural gas. If you and the usual product is gray methanol, so all the large plants, the large methanol plants are producing gray methanol. If you capture the CO2 or use it in a closed system, so make sure that it is not emitted into the environment, you can call it blue methanol. And then you become greener. As soon as you have renewable power, you get a green element into the system. If you have just a classical CO2 from let's say from a power plant, or no, not even from a power plant, from a steel plant or from a cement plant or chemical CO2, then you are still in the blue range. But if you have green hydrogen, green CO2, you are entering your green methanol area. And that is the same when you are using biomass, gasify it, or use biogas, make syngas, you are entering green methanol. So this is a quick overview over the color of methanol. Here's a view of consultants about the increasing methanol demand over the next years. And these are the applications. I'll come back to that in a little bit. Here's a more bold forecast from IRENA and the Methanol Institute. There's a published paper where they are saying that within the next 30 years, methanol demand will increase to 500 million tons per year, where the largest part is really renewable methanol. I wanted to share that with you because this is a little bit the base for the discussions we are having in other parts of the world, especially in Europe. But that is something, it can be really debated. And is that really possible with all what we have today for the production of renewable methanol? I don't want to miss those two slides, methanol use 2020 versus 2012, you can see that let me see, where's the red line is 2020, the blue line is 2012. So you still see that the largest consumer for methanol is formaldehyde, and the second largest is methanol to olefins. And really this application area of methanol to olefins developed over the last 20 years from zero to a basically number 2 position today. And then you see a range of fuel applications and chemicals applications. Here, a quick look at the prices of methanol. It's not at all a stable price situation. It follows oil pricing and definitely supply-demand situation. And you can see over the last 20 years, it is an up and down of prices, more following the supply-demand than really the oil price. And right now, we are in a very high price level for methanol, which makes it difficult again for Chinese olefins producers to follow and to use methanol. We had that slide, I just skip it. Let me come to this one. So this is the problem we are having today in the whole renewable methanol discussion. If we talk about biomethanol, which is coming from biogas, from biomaterials gasification, we talk about a price between 450 manufacturing cost of $450 to $1,050 per ton. Contract price in the US today is at almost $600 per ton, and I said it's a very high level. So at this time, manufacturing cost is much lower. In the US, we are talking about cash cost somewhere $120, $130 per ton. So it's a multiple. The biomethanol price is a multiple of manufacturing cost of classical gray methanol. The same for e-methanol, it's even worse. I mentioned earlier that you have to provide hydrogen via electrolysis, and power is expensive, capex is expensive, and CO2 has to come from biosources. This makes the renewable discussion very, very difficult. So we thought about how can we solve the problem, or how can we offer a midterm solution for entering such a low carbon methanol world. First of all, we have to focus on very low CO2 emission methanol, call it blue methanol. We are using classical feedstock, but apply technologies where all carbon ends up in methanol and no or little CO2 is emitted. And then we try to streamline the plant capex to a level where a product can compete against classical gray methanol. In a first step, and I'm sorry, this is a typing mistake. In a first step, we are using natural gas as feedstock, not biogas. And then we prepare the plant for a stepwise replacing of fossil feedstock by renewable CO2, green hydrogen, and bio-based feedstock. And that is what I would like to show you today. Here's a classical methanol plant. Natural gas is injected in a so-called partial oxidation reactor or autothermal reactor, which is a closed system. It's a vessel with insulation inside, chamot inside to hold high temperatures, and a burner system. In case of partial oxidation, there's no catalyst in it. In case of ATR, there is a catalyst in it, and Lurgi Technologies can offer both reactors. The advantage of an autothermal reforming is it's a better ratio between CO and hydrogen for methanol. Partial oxidation is a little short on hydrogen and needs some co-feedstock from the hydrogen side. And then you compress the syngas, go into your methanol reactor, and all of your syngas, which is CO, CO2, and hydrogen, is consumed in the methanol reactor. So, and then there is a classical distillation. For smaller sizes, we would say you need a 2-column system, maybe even a 1-column system. We are working at that. New technologies implemented are on the way to reduce the capex. And at this moment, we are talking about, for such an application, we are talking about smaller plants, say somewhere around 100,000 tons per year. The beauty of using partial oxidation or autothermal reforming is that you can even take natural gas at a high pressure at 65 bar, which is more or less the pressure of our methanol reaction, and skip your syngas compressor, which is a large capex cost, and it's a large capex cost, and it's an operational headache for methanol plant operators. So that is the setup. Nothing very special, but something that can be implemented and make in a first step gray methanol, and converted in a later phase to a green or renewable feedstock. It has to be said that the best setup for this system is within an existing production, let's say production cluster, ideally petrochemicals, because we need a little bit of additional hydrogen in the system. That can be a very crude hydrogen, a waste hydrogen with other hydrocarbons, especially if you apply a partial oxidation. That partial oxidation can take anything and convert it to methanol. Yeah, we have done a case study, 250 tons per day of methanol, which is slightly below 100,000 tons per year. Natural gas feed at $3 per million BTU. The POX unit for syngas production cost of methanol would result in $250 to $300 per ton. And CO2 emission is approximately 90 kilograms per ton of methanol, and that could be reduced close to zero emissions. Just to keep in mind, the large plants, our mega methanol plants, where we are the technology market leader, is emitting 330 kilograms per ton, 330 kilograms CO2 per ton of methanol. And the steam reformer-based plants are even higher, close to 400 kilograms per ton of methanol. Yeah. So this is the idea to set up, and then an immediate impact is that the POX has no burning chamber. We have in a few cases, and that has to be decided case by case, a small fired heater that would emit some CO2. But everything that goes into the POX or into the ATR, the produced CO2 is directly recycled into methanol. There is oxygen required for an operation of a POX or an ATR, and that avoids any nitrogen in the system. The oxygen plant can be operated with power, ideally with green power when we go later into the renewable part. The midterm value is that we have a small stream of CO2 from the fired heater, which can be extracted and used as a feedstock in the plant as well. And hydrogen and CO2 from the tail gas can be returned into the reactor, so also that CO2 is recycled. And the long-term potential, and that is the interesting part, is you can step-by-step replace your non-renewable feedstock by biogas, by green hydrogen, by CO2. So the beauty of the plant is you have a plant installed with a reasonable capex. You make a product which you can sell at a reasonable market price, and then you have all the time to turn your plant into a renewable methanol plant. So you can basically overnight, as you have your feedstock available, turn your plant step by step into a renewable, into a green plant. This is in a nutshell what I wanted to share with you. A few last words. The the methanol molecule can be used to capture carbon. This is a fact, and this is widely discussed. The methanol production process can be designed for minimizing or even avoiding CO2 output, as we have shown. And low carbon methanol can be produced at cost of classical gray methanol. And the Lurgi Methanol Technology offers technology with high flexibility for making methanol from blue all the way to green, and following the transition stages. So this is the end of my presentation, and I'm very happy to receive questions from the audience.
Thank you, Matthias. If you can stop presentation in order to see faces of the people, thank you. Well, everybody, if someone want to send me some, I will start with the first question, Matthias. Something very interesting that you mentioned about the carbon capture. Do you think that the methanol production in this way is a good option for the industry to capture carbon in order to achieve the objective of zero emission in many petrochemical industry?
I would say it's a first good step. If you look at 100,000 tons plant, your CO2 that you are reducing is not much. I mean, the benchmark is already a tough one. The large plants are emitting, as I said, 330 tons per ton of methanol. So it's not a huge CO2 emitting plant anyway. And then you go down and you go a significant step down. It's not solving the CO2 problem of the world, but it's a good first step for companies that would like to go into green later and are afraid of investing because that is not producing an economical product, to go first into this and then step by step go into green. So that is a first good step up, but it is not solving the CO2 problem of this world. Okay,
thank you. Marcelo, you have a question. Please go ahead.
Yes, thank you, Matthias, for your presentation. Very nice. So just one question. When I saw your figures in the presentation, I was wondering if the oxygen was included in that, because I think that the POX will, I guess ITR also will need oxygen, right?
Yeah, the oxygen is included in this.
Is included.
I think I mentioned what was it? 300? No.
That
330 tons, I guess. $330 per ton, I think I mentioned, yeah.
Okay.
Yeah, it's included in that, yeah.
And I have another question regarding green hydrogen. It could be possible to have some kind of mix of both technologies. I mean, to use part of the hydrogen as from electrolysis and put in the process and.
Yeah, absolutely. And that is your most likely case. When you do it, you start with small quantities, depending on how much you have available and how much you can afford to put into the plant. I mean, it's a cost factor at the end if you want to make green hydrogen. If you want to start small, you can inject it, and then your outcome is your methanol has only a certain percentage of green.
Okay. Because in that case, I was thinking that it would be nice to use the oxygen that coming from the electrolysis in the POX.
Absolutely, yes. This is a calculation at the end because your oxygen has to be compressed. So you have to look at how much is the cost for compression. You are anyway a little bit in the dilemma to look at your capex optimization on one side and your how can you make your plant ready for green on the other side.
Okay. Thank you.
Para la audiencia, y si alguno quiere hacer alguna pregunta, levanta la mano o manda algún mensaje y le damos la entrada. I have another question, Matthias. Something that surprised me was the use of methanol. The first in the ranking is the methanol to olefins. I thought that the fuel was the first one, and you are mentioned that in one slide that that application. Do you think that this will increase the use for methanol to olefins or the fuel in the future as this energy transition will increase more?
I guess the fuel application will be the application of the future. The large shipping companies are already discussing methanol as a fuel, or at least as a co-fuel for others as well, especially in the area where the emissions from ships are very, very limited, where you have to really use low sulfur diesel or fuel oil. Then it makes sense to consider methanol. And I know there are a lot of discussions ongoing with shipping companies like Stein in Europe, like Maersk, the container shipping company around the world, and also with manufacturers of equipment. So MAN is very deeply in this subject to use methanol as fuel, as a combustion fuel. And also Wärtsilä in Finland is working at that heavily. And there are others as well. Those are only the most known companies. So.
Great. Guillermo, you have a question, please go ahead.
Yes, thank you, Gabriel. It's a question a little bit in the same direction. You mentioned in your presentation that the growth expectations of methanol to olefins was the higher by far. It was like 5 times the current consumption. Do you expect a growth in the polyolefins or olefins demand, or you're expecting a full replacement of the regular or current production processes? Why it's such growth in olefins?
Methanol to olefins is a phenomenon of China. So while you have inland, where you have the coal sources, a lot of coal-based methanol production and then converted to polymers inland and consumed inland, you have a lot of these MTO plants along the coastline. And traditionally, China has the lowest price spot methanol. China is only buying spot. And the lowest price of spot methanol is always in China. And that's why these companies started to think about, is it economical? And they have started to build methanol to olefins plants based on imported methanol. There's one point that comes on top. China is traditionally the sink for Iranian products, because that is product that cannot be freely traded around the world. The Iranians have to discount their product and sell it to China for a reduced price. The same was and is basically valid for India. So for them, it's a good source to get, let's say, very low price methanol for their olefins plants. But on the other side, you have to say, once methanol becomes more expensive and the olefins prices are not as high as they would need to be for a higher feedstock methanol, these plants are quickly shutting down. So it's a kind of a swing capacity we are seeing in the market. So.
Thank you.
Thank you, Matthias. Anybody in the audience wanted to make a question? We have a very good audience here.
Yeah.
I don't want to, you know, select the people, but we have a very well-known people in the audience attending this presentation. Well, if we don't have any question, I will make the closing. Matthias, if you want to make some words, and then Marcelo closing the presentation. Matthias.
Yeah, thank you very much for your attention, and it was a pleasure to present in front of this audience. Unfortunately, I would have, or not unfortunately, I would have preferred to do that in person, not virtually. But maybe next time, maybe at the next APLA, we can do that in person.
Right.
Thank you very much. And if there is anybody who wants to talk one-to-one, I'm available. Marcelo has the email, so we are available and we can speak. Thanks a lot and enjoy your day.
Thank you, Matthias. And thank you the IPA that invited us to make this presentation. I will attend any question that you would have in the future for this technology and for others that we can help. The idea is just to be here to support you in your next energy transition. We have this and other solutions that we can offer our customers. As I tried to present in my introduction, Liquide is really committed to this task in the future. So we are here just to help our customers in your process and try to develop and support you in the future. So thank you very much for all, and that's it for my side. Thank you, Matthias, again.
Thank you. Thanks, everyone.
Gracias a todos. La grabación va a estar en el canal YouTube del IPA, y cualquier pregunta nos pueden contactar a mí, a Marcelo.
Y la presentación la podemos compartir porque es pública, así que se las mando en PDF después si la quieren subir al site del IPA, no hay problema.
Perfecto. Bueno,
Okay.
Muchas gracias a todos.
Bueno,
buen día.
gracias a todos.
Thank you, Matthias. Bye.
Buen día.
Matthias.
Bye.